Okay, in this video, we're going to walk through the synchronous file I/O methods of Node.js. So what it means by synchronous file execution methods, I'm referring to the fact that these operations are basically going to be blocking operations. So what that means is that the system essentially is going to wait until the operation finishes before moving on to the next task. Okay, so again, the characteristics of this kind of operation for these types of methods is blocking, where the execution is going to stop until the operation completes. So there's nothing else happening within the event loop while that's going on. So essentially, you can think of this as a sequential execution. Okay, so it's only going to execute one method at a time. Okay, so the flow is easier to understand. Obviously, it's just a much simpler process, but there's obviously a lot of performance drawbacks with the synchronous. However, this is a good starting point for understanding how some of these methods work within Node.js. So in order to use the file operations within Node, we need to create a Node.js module, which is I did here. I have a file called synchronous.file.io.js. And in order to start using the methods for file.io, I need to include the FS or file system module, and I'm using the require function in order to pull in that module and assign it to a constant. So that by doing that, I will have access to all the methods, synchronous and asynchronous together. We can do, but again, we're talking specifically about the synchronous file I/O. All right, so reading and writing to these files, how do we do that? Well, the first thing is we can use a couple different mechanisms. The first one is what is called the write file sync function. Okay, and again, I'm going to be using our file system, or FS variable, or constant, I should say, and I'm going to be accessing the write file sync method. It's important to note that all of the synchronous functions or file I/O functions are going to have a sync or suffix to them. So you can tell right away if you're using a synchronous file I/O method, okay? Which is what we are in this module. And so we're going to take a couple parameters here. The first parameter is going to be the name of the file that you want to write to. And secondly is going to be whatever it is that you want to write to that file. This could be a variable, it could be a constant. In this case, it's a string that I'm writing out to the file. So you can have a buffer variable that you're storing everything in. But this is the simplest version here, and that's kind of why I'm showing it this way. All right, so when I run this, it's going to write to that file. If the file doesn't exist, it's going to create it. And if the file does exist, it's going to overwrite what's there, okay? So let me go ahead and first off, let me show you how this works. Also important to note here, the file name itself, you can include a path to that. I am not including any path, so essentially it's going to be writing in the same folder where the script is executing from. Okay, so it's going to be executing and writing this file out to the same folder where we're at now, our execution folder. If you want, you can provide a path. So I can say, home user, whatever that path is, you can provide a full path to that file, and it'll write and read from that full path. So you have the option, and a lot of times it is important to include some type of path with it. However, to keep things simple, I'm just going to not include a path here. So that means the file is going to be written to the directory that we're currently in. And what's nice about that is you'll actually see the file show up here inside of our Explorer as I do this. All right, so let me go ahead and save this. I'm going to come down here to my terminal window, and I'm going to first off do an ls and see the files that are in there. All right, here is my script, and I'm going to type node followed by the script name, and I just simply hit the tab key. If you type a couple characters and hit tab, it will fill out the rest of the file as best it can based on what you typed in. So it's kind of like a quick way to type out a file, type out a string without having to type all the keystrokes. All right, so I have that, run that. Okay, now immediately once that runs, I come up here and I can see my notes.txt file sitting here. So there's the file being written. I can also do an ls here, and sure enough, there is the file. All right, if I click on it, I can see there's the string that I wrote out using that function. All right, so that's how we can write to a file using the synchronous methods. Now, a lot of times, if you'll notice, if I run this multiple times, okay, if I hit the up arrow, by the way, if you hit the up arrow, will repeat or show you the past history commands you wrote. So it's an easy way to rerun a command that you ran previously without having to retype it. So I just hit the up arrow to get back to that command that I ran. I'll hit it again, up arrow, hit it again, and I'm running this function multiple times, and you'll notice when I do that the file is still simply that one line. Okay, even though I was calling write file sync multiple times, right? Every time the script ran, and that's because this function overwrites what's there. So it just overwrites and writes a brand new file out each time. Now, a lot of times that's not always what we want. There are times where we want to append to a file, all right? And so there is an equivalent function called append file sync that operates very similar to the write file sync, except it will, if the file is already there, it's not going to overwrite it. It's simply going to append it to that file. So I'm going to go ahead and comment out my first example here. Save this. And if I run this multiple times, hitting the up arrow each time, all right, clear that out. If I come up here and look at my notes.txt file, you'll see that the content has changed, but the append method simply kept adding on to the file that was already there. So we have both are important. You have to be able to do both for various use cases, whatever you're trying to do. So that's why there's two different functions to provide that capability. All right, next up is once we have our file, let me go ahead and comment this out. Once we have our file, we need to be able to read it. All right, so the way we do that is by calling the read file sync method and providing the file name that you need. There are other parameters beyond that, but the simplest form takes just the file name. And what's going to happen is it's going to try to find this file, and then it's going to read the content and put them into that constant or variable, wherever you're trying to store it to. Once I have it in code, I can then use the console log, simply print out what's in that variable or constant. So I'm going to go ahead and save that and come up here again. And this time I'm going to run it again. This time it's going to run that line 10 and then print out on line 13 whatever is in that variable. And I should see all of the contents of the file, the notes1.txt file, written out here. Okay, so that's how we can read and print the contents, and read the contents into a program and also print them out. All right, next up is let's talk about some of the other characteristics and options we have with some of these functions. So I'm going to comment out this example, and I'm going to come down here and uncomment this one. First example is how do we set encoding? You can set encoding for the file by specifying the second parameter as the encoding type. And so what is meant by encoding simply means what character set is being used for the file itself, for the data. So UTF-8 is the predominant kind of standard de facto standard encoding for the web, if you will. So 90% of web pages use UTF-8 encoding. You might see other ones like UTF-16. There's other ones out there too, but they're just simply describing the character set and how the data is formatted. Okay, UTF-8 is a standard. If I run this, I'm not going to see any different than what I did before because it's actually the default encoding for Node.js is UTF-8. All right, so you can specify that by providing the second option. Again, the only one that's really required is that first one. Obviously, specify the file that you're trying to read from, and then you have these other ones after that. All right, so this first example. Next one is you can specify the file permissions. All right, so the file permissions are ways that you can specify how you want that file to what are the permissions you want to set on that file? Okay, by setting the file mode, the permission mode. Okay, permission mode is simply something that is part of, again, I'm on Linux, so all files have the ability to, you can specify how you want the file to be, what permissions you want to set in the file. Do you want someone to be able to read it? Do you want someone to be able to write it? Who do you want to be able to read it? Who do you want to be able to write it? Is it an executable? Okay, you can specify all these different permissions, and there are actually 3 sets. First set is the owner, which corresponds to this first value. Second set is the group that it belongs to, what can they do? And the third one is everybody else. Okay, so you have set of 3 different values and set there. Without getting into too many details, a 7 simply means that the owner has the ability to read, write, and execute this file. And a 0 means that 2 zeros mean that nobody else does. No one else can see it. So if I run this, and I do an ls-l on the file that I'm creating here, you'll see that notes2, which is the file that this would have created. I read it before, that's why I'm not running it again. You kind of see these permissions, all right? And the one that we wrote earlier has a slightly different version here, right? So you can kind of see we kind of helped set how we want this file to be written out. So the write file sync function has the ability to set additional properties of a file, right? Very important to understand that, okay? But the default, obviously, it uses what you see here, right? So it's read-writable by the owner, it's read-writable by the group that owns it, and it's read-only by everybody else. But I can change that to a different permission set simply by using that mode option within the write or read. Okay, well, actually it's the write, because I'm writing the file out. Okay. All right, next up, let's go ahead and comment this example out. Let's go on to the next example. It's very important whenever you're dealing with files that you handle errors that may occur. For example, we don't want the program to just die or completely get killed by the operating system. And by default, if you have exceptions that happen, and again, you know this from other languages, if you've done anything with Python or Java, they all kind of do the same thing. There's exceptions that get raised if there's an error, and if you don't handle those exceptions, the operating system will then just kill that program. Okay, and it's an ugly message, and it's not typically what we want. We like to try to put try catch blocks around code that is suspect or could have issues, especially in file I/O. There could be errors that could pop up. For example, here I'm trying to read a file, but it happens to be a file that doesn't exist. Notes 122 doesn't exist. So normally if I try to do this read file sync and the file didn't exist, I would get a big ugly message and the program would just stop, right? So by putting a try catch, I can simply handle it more gracefully and say when that error occurs, then I can check and see if it's an error that I can handle. I go ahead and give them a nicer message. So if I run this again, clear this off and run it, you'll see that I get a nice message rather than a more verbose message if I didn't have it. For example, if I commented all this out, all right, and I didn't have a catch block, and I run this again, you'll see that I get much more kind of a lot of information here, right? So, and the program was killed by the operating system by doing that because there was no exception handling occurring, okay? So try catch blocks keep the program alive and give us a way to gracefully handle errors that we anticipate. All right, next up is we've been showing you the simple ways to use the file I/O. Pretty simple, one line of code typically. Unless you have an exception block, it's get a little more complicated. But we also have the option to use what are called file descriptors. So think of a file descriptor as kind of a value that points at a file, all right? And rather than having it just open and close or do everything in a single function, we can keep a file open and we can use this connection to the file for more than just 1 or 2 lines of code. Okay, so Here I'm using the OpenSync. I'm giving it a file name. I can also provide how I want that file to be opened. Read is R stands for read, so I'm going to open this file for read purposes. And then what's going to happen is I'm going to get back a pointer or a handle, if you will, to that file. And then once I have access to that file pointer, I can then create a buffer and read in the data into that buffer. And that's what's happening here. So you can kind of see, we're talking about adding a lot more here to do it, but again, it's a more powerful way because you have more granularity in terms of how you want to use the file, what you're doing with it. So you're not just opening and closing it right away. You're keeping it, or you're doing something else with it. So the file descriptor approach is the way you do that. So if I run this program, let me go ahead and clear this. And if I run this and I try to read that Node.js file, it's not gonna behave any differently. I do have an additional line that I'm writing out here, which is the file descriptor that I got from the open. So I got back a value. So think of that as just a handle to the file itself that the operating system gave us. And then once I have that, then I can use that file descriptor to go access that file through that handle, and I can provide it the ability to read in the data, convert it to a string, and print all out. So there's additional things we're doing once we get that data read in from that file. Okay, but that's definitely an alternative way to what we have been doing. It gives us more granularity, more flexibility, and it is alternative to the simple reading, writing with a single line of code. All right, go ahead and comment this out. Let's talk about the next example. All right, now we also can write out objects to a file. So what I'm showing you here is I can create an object. All right, so this is simply a simple JavaScript object called book, and I've got two name value pairs, title and a value that goes with the title, and the author and the author's name. So simply is just an object that we can define as part of one of the data types that we have within JavaScript. Right? What I can do with that is I can write that content to a file same way. So I don't not just stuck with just writing strings, simple strings. I can write complex data to a file. So if I go ahead and save this and come down here and run it, I'll see that I have my book.json here, and there it is. So I've written this file out in JSON format. And I can obviously read that file back in the same way. So I'm still using the same write file sync that we were using above. So let me go ahead and comment this all out. All right, and I'll go ahead and read that in from a buffer. And print that out. All right, go ahead and save that. And run this again, clear this out. There you go. So I read that value. So you have the ability to read in complex data, and you have the ability to write out complex data. You have the ability to write out strings like we showed you. So lots of options here in terms of what type of data you're trying to read and write out to files. All right, lastly, let me go ahead and comment this all back out again. Let's go on to the next example. And here, we're actually going to show you that we can write out things in even hexadecimal format. So I have a data that is a buffer, which is nothing more than just a way to we can store some data in there in a buffer string. And this is something that's specific to Node because we're dealing with files here, and that's not something that's in JavaScript that's specific to Node.js, had the ability to have buffers. So I'm reading and creating a buffer of some characters, and then what I'm going to do is I'm going to print out that buffer to a string in hexadecimal format, and then I'm going to write that format out to hex.text. So I'm going to go ahead and save that. I'll come down here and run this. There it is. There's my hex.text. So here I've got my data. So it's the data you see here, hello world, but it's in hexadecimal format. So that is hello world in hexadecimal format. Okay, so you have the ability to write that out, and all I did is write it out. I called the toString function or method off of the buffer, and I provided how I want that, what format do I want that to be written out in. So you have the ability with toString to provide the encoding that you want that string to be written out as, hex being one of them. All right, hope you find this useful, and we'll see you in the next video. Thanks.